Determine the limit as x approaches positive infinity and as x approaches negative infinity of the square root of 9x squared minus 6x minus 4 minus 3x. Starting with the limit as x approaches positive infinity of the square root of 9x squared minus 6x minus 4 minus 3x, the first thing to do is try plugging a positive infinity in for each of the x's. Only the highest power terms will matter here. Plugging positive infinity in will give positive infinity squared, which is positive infinity, times 9, which is positive infinity, and the square root of positive infinity is positive infinity, and then minus 3 times positive infinity, which is minus positive infinity. The result is positive infinity minus positive infinity. We have the infinity minus infinity indeterminate form here. We will need to rework this. Since it resulted from a root combination, a root involving x in some way added or subtracted together with at least one other term, we can make use of the root conjugate. Rewriting the original limit exactly as is, we can form the conjugate, which is the same two terms in the root combination, but opposite sign between them. So instead of a minus 3x, it'll be plus a 3x. We can put this over itself so that we have a form of 1, so that when we multiply by it, we will not change the value, just the look. The original expression can be put over a 1, so that when multiplying, we can multiply the denominators as well as the numerators. We will now multiply these together. In the numerator, we have a root conjugate pair. We will FOIL it out. First, root times root will be root squared, which cancel each other out, and we're left with what's inside there, which is 9x squared minus 6x minus 4. The outside term will be root times positive 3x. The inside term will be negative 3x times the root. Those will cancel each other out. And the last term will be negative 3x times a positive 3x, which will be a negative 9x squared. All of this will be over the denominator, which is 1 times the root conjugate, which will result in just the root conjugate. 9x squared minus 6x minus 4 plus 3x. In the numerator, we can combine like terms. The 9x squared and the negative 9x squared will cancel each other out, leaving a negative 6x minus a 4 divided by the root conjugate. If we try plugging the positive infinity in now, only the highest power terms in the numerator and denominator matter. In the numerator, that'll be negative 6x. In the denominator, it will be the square root of 9x squared as well as the 3x. In the numerator, plug in the positive infinity. Negative 6 times positive infinity is negative infinity. In the denominator, positive infinity squared, positive infinity times 9, positive infinity, square root of positive infinity is positive infinity, plus 3 times positive infinity, which is positive infinity. Positive infinity plus positive infinity is positive infinity. The result is negative infinity over positive infinity. We have the infinity over infinity indeterminate form here. We will need to rework this. And it is reworked by dividing both the numerator and denominator by the highest power of x in the denominator. The highest power of x in the denominator will be x squared under a square root, which is x, as well as another x. And so the highest power is x to the first power. We'll now divide the numerator and denominator by x to the first power. In the numerator, each term can be divided by x to the first power. In the denominator, the entire root can be put over x to the first power. And the 3x can be put over x to the first power. In the numerator, the first term, the x's will cancel, leaving a negative 6. In the second term, there are no x's to cancel. It will remain as negative 4 over x. In the denominator, the square root can extend over the x. By rewriting it as x squared, because the square root of x squared is x. In the second term, the x's can cancel, leaving a positive 3. Leaving the numerator alone, in the denominator, each term under the root can be put over the x squared. And now some x's can be canceled in the terms under the root wherever possible. The first term under the root, the x squareds will cancel, leaving a 9. The second term, one of the x's from the denominator can cancel with the x in the numerator, leaving a minus 6 over x. The third term has no x's to cancel. It will remain as a minus 4 over x squared. Each term that is a constant divided by x to a positive power will go to 0 as x approaches positive infinity. The result is negative 6 minus 0 divided by the square root of 9 minus 0 minus 0 plus 3. Negative 6 minus 0 is negative 6. The square root of 9 minus 0 is the square root of 9 plus 3. The square root of 9 is a 3. 3 plus 3 equals a 6. The 6's can cancel, and the result is negative 1. Now to work out the limit as x approaches negative infinity. The square root of 9x squared minus 6x minus 4, and then minus 3x. The first thing to do is plug negative infinity in for each of the x's. Only the highest power terms matter here. We have the square root of 9x squared, as well as the minus 3x. Plugging in negative infinity, and negative infinity squared is positive infinity, times 9 is positive infinity, and the square root of positive infinity is positive infinity. And then it will be minus 3 times a negative infinity, which will be negative infinity, minus a negative infinity is positive infinity. The result is positive infinity plus a positive infinity. Infinity plus infinity will equal a positive infinity. And there's the results of the two different limits.